Welcome to this video. In this video, we will study laws of chemical combination. Friends, we know that elements combine. But some of you would be interested to know how and why do the elements combine? What happens when the elements combine? Like us, scientists were also interested in all this. One of these scientists, Antoine Lavoisier, established two important laws of chemical combination, which provided an important foundation for chemical science. Let us now begin our study of the laws of chemical combination. Two laws of chemical combination were established after much experimentation by Lavoisier and Joseph L. Proust. Let us look at the first law. The first law is the law of conservation of mass. Friends, when there is a chemical change or a chemical reaction, is there any change in mass then? Let us try to find the answer through an activity. Prepare two separate solutions of 1.25 grams of copper sulfate and 1.43 grams of sodium carbonate in 10 ml of water. Now, take the sodium carbonate solution in a conical flask and take the copper sulfate solution in a small test tube. Hang the ignition tube in the flask carefully. See that the solutions do not get mixed. Put a cork on the face of the flask. Now carefully weigh the flask containing the contents. Tilt and swirl the flask in such a way that the copper sulfate and sodium carbonate solutions are mixed together. Now you may be wondering if there is any reaction in the conical flask. Here, copper sulfate, sodium carbonate react, and blue copper carbonate and sodium sulfate solutions are obtained. Now weigh this flask again. What do you see? Has there been any change in the mass and contents of the flask? There is no change in the mass of the flask. By this activity, we can define the law of conservation of mass in this way. According to the mass conservation rule, mass cannot be created nor destroyed in a chemical reaction. Let us now take the second law of chemical combination, law of constant proportions. Activity 2. If we take 10 ml of water from a waterfall in a test tube and 10 ml of water from a lake in another test tube, can you tell whether the proportion of mass of hydrogen and oxygen in both these test tubes is the same or not? Yes, it is same. You will find that the proportion of the mass of hydrogen and oxygen in the water of both the test tubes is 1:8. Similarly, irrespective of the source of water, you will find that the ratio of the mass of hydrogen and oxygen in water is always 1:8. Similarly, if you decompose 9 grams of water, 1 gram of hydrogen and 8 grams of oxygen will always be obtained. Lavoisier, along with other scientists, noted that many compounds are composed of 2 or more elements, and each such compound had the same elements in the same proportions, irrespective of where the compound came from or who prepared it. Let's take another example of this. If we take the example of ammonia, nitrogen and hydrogen are always present in the ratio 14:3 by mass, whatever the method or the source from which it is obtained. These examples explain the law of constant proportions, also known as the law of definite proportions. This law was stated by Proust as, in a chemical substance, the elements are always present in definite proportions by mass. Scientists defined both these rules, but the next problem faced by them was to give appropriate explanations of these laws. Dalton presented a fundamental theory about the nature of matter. Dalton provided the idea of divisibility of matter. Dalton also named the smallest inseparable particle of matter as atom. Dalton's theory was based on the laws of chemical combination. Dalton's atomic theory provided an explanation of the law of conservation of mass and the law of definite proportions. We will discuss Dalton's atomic theory and what is an atom in the next video. Friends, today we studied the laws of chemical combination. In the next video, we will study what is an atom.